A hospital is trying to cut down on emergency room wait times. It is interested in the amount of time patients must wait before being called back to be examined. An investigation committee randomly surveyed 70 patients. The sample mean was 1.5 hours with a sample standard deviation of zero point 0.5 hours. Construct a 97% confidence interval for the population mean time spent waiting by answering the following questions. First, we summarize the problem using symbolic form. 70 patients, that is a sample size, so n equals 70. 1.5 hours what the sample means, so this is x bar equals 1.5. 0.5 hours is the sample standard deviation, so this has to be s equals 0.5, not sigma. And so in this case, sigma, or the population standard deviation, is unknown. We are constructing a 95% confidence interval. And in this case, since sigma is unknown, we would need to follow the proper procedure. A. Are we constructing the confidence interval for the proportion p or the mean mu? If we read the question carefully, we will see that we're looking for the confidence interval for the population mean. And so the answer is the confidence interval for the mean mu. That is part A, mean mu. For part B, what critical value should we use, z or t? We use the critical value z if sigma is known, and we use the critical value t if sigma is unknown. So in this case, we will use t star since sigma is unknown, which means that we only know the sample standard deviation, but we do not know the population standard deviation. If z should be used what it is, we ignore it. And if t should be used, what is the degree of freedom and what is t? For simplicity, we will use the degree of freedom to be one less than the sample size. So the degree of freedom is 70 minus 1, or 69. And to find the critical value t, we would need to use the t table or the t calculator. In this case, we are using the free StatGrunt t calculator. We click the feature between because we are interested in the confidence interval in between here. We input the degree of freedom, which is 69. This is very important. The same level confidence interval would give us the different critical value t for different sample size or different degree of freedom. Since the sample size is 70, the degree of freedom is 69. We leave the two boxes on the left and on the right of the symbol x empty, and we want the 95% confidence interval, so we would input 0.95, which is the area in between, and we hit compute. The critical value t is 1.9949, which we will round it to two decimal places, 1.99, and that would be our critical t. So t or t star is 1.99. Part D. What is the standard error of the sample mean? The standard error is the sample standard deviation as divided by the square root of the sample size n. The standard deviation of the sample was 0.5 divided by the square root n is 70. 0.5 divided by the square root of 70 is 0.06, rounded to two decimal places. E. What is the margin of error? The margin of error is the critical values times the standard error, which is s over the square root of n. And so this is 1.99 times 0.5 over the square root of 70, or simply 1.99 times 0.06, because we computed 0.5 divided by the square root of 70 earlier. Rounded to two decimal places, we will get 0.12, and this is the margin of error. Once we get the margin of error, we would construct the confidence interval. The confidence interval is computed using the point estimator, in this case for the mean x bar plus or minus the margin of error, where we computed the margin of error already. And so this is 1.5 because the sample mean x bar is 1.5 plus or minus the margin of error was 0.12 we computed. There are two computations here. One is 1.5 minus 0.12 and the other is 1.5 plus 0.12. 1.5 minus 0.12 is 1.38 and 1.5 plus 0.12 is 1.62. And so the confidence interval is 1.38 as the lower bound and 1.62 at the upper bound. We say that we are 95% confident that the true mean is between 1.38 and 1.62. And in the context, we might say we are 95% confident that the population mean time spent waiting, we might want to be a little bit specific there, is between 1.38 minutes and 1.62 minutes. What this means is that if we were to construct 100 confidence intervals, 95 of those intervals will have the true mean, which is between 1.38 and 1.62.